All right, so we're going to talk about more on functions, and we're going to talk about increasing functions, decreasing, and constant functions. So here we have a function where it increases. A function increases on an open interval of its domain. Think about the x coordinates here. If its graph rises from left to right. Okay, so we have, as we read a graph, we want to make sure we read it from left to right. Okay, so increasing. Decreasing, a function decreases on an open interval of its domain if the graph falls from left to right on the interval. And then we have what's called a constant function. A function is constant on an open interval if its graph is horizontal on the interval. Okay, so it doesn't move, it stays as constant. So as we look at and talk more and look at some graphs, we're going to talk about how to identify where it increases and decreases. Now, what's going to be so key to you um, determining if it's increasing or decreasing, and let me set this up just a little bit so that you can see all of this. Um, The concept of increasing and decreasing functions apply to intervals of the domain. Let me highlight this or underline. And not to individual points. This is going to be so key. We're looking at the domain, the x coordinates, the x values, the independent variables. The definition of increasing and decreasing functions require that the x interval be an open interval. Open, okay. An open interval does not include endpoints. So when we talk about open intervals, we're talking about using parentheses. And we use interval notation with x values. This is very, very, very important. Okay. So as we talk about increasing, decreasing, and constant functions, we're using interval notations with x values. So let's look at our first example. So keep in mind, let's imagine that I didn't have the coordinate of y here. Okay, or excuse me, the y-axis here, and we just had the x-axis, and I want to find where does it increase, where does it decrease, where is it constant, if necessary. So we're going to read this graph from left to right, and as I read the graph from left to right, I notice starting from the left, I'm starting at a continuous point, meaning this is going to be negative infinity because we're starting on the left hand side. And from negative infinity at 1, we're talking about the x-axis, x values at 1, that's where it decreases, this parabola. So we will write this out as negative infinity comma 1, and we're going to write it as an interval notation. Okay, an open interval. So it decreases from negative infinity to 1. Then where does it increase? That's what we want to find, because if you notice, as we from 1, reading it from the left to the right, it increases to what? Okay, to positive infinity. So we would say open parenthesis 1 comma positive infinity. This is where it increases. Okay, and then We do not have a constant function. Okay. All right, let's do another one. We have a graph, no particular name, going from left to right. So from left to right, from this arrow, and it's going to the left, so that means that this is negative infinity. Okay, so looking along the x-axis, the x values, from negative infinity to what? Where do you see a transition at what number? 1. So from negative infinity to 1, it is constant. Here's our 1. We're not looking at the y value. We're looking at the x value. Look at the x values. Okay. So it stops at 1 where it's constant. Then there's a transition where it's going downward, meaning that it's decreasing from 1 to positive infinity. So interval notation is nothing new. We've talked about interval notation. We spent a lot of time on that, but I definitely want you to understand what does it mean for a function to increase, decrease, or when it is constant.